Hey folks, welcome to Coalesce, and I hope you're all looking forward to this talk. My name is Mark Maxwell. I work for DBT. I'm leading the go-to-market charge in EMEA for our cloud products. And this is a talk I've been really looking forward to because over the past while, I've really noticed an increasing popularity in the data mesh approach. So I'm super interested to hear how DBT can work with that. And super interested to introduce our speaker today, who is Jose Cabeda. He's a data engineer in TalkDesk. He seems to have had a really interesting experience with data mesh so far, had a large impact on TalkDesk, and is particularly interested in the impact that data mesh can have, how startups can scale their data infrastructure in particular. So I'll get out of the way and leave it to Jose to run you through.
Hi everyone, really great to be here. Thanks for the invite. Today I'm going to talk a bit about some of the issues that we had trying to scale up and how DBT helped us and what the hell is data mesh. But to start it all up, I'm Portuguese. I come from the port wine city and I'm also a bookworm, especially love Harry Potter books. But at least for this talk, I'm a data engineer, TalkDesk, and I think actually it's the most important point from all of what is TalkDesk. TalkDesk is a company that was founded in 2011. It started in a hackathon sponsored by Twilio, and we provide a contact center as a service, or what we like to call a CCash. And this is nothing more than each company needs to have support for their clients. We provide a service in the cloud for them to be able to make calls, receive calls, send messages, what they need to make their customers happy. And another relevant point is the fact that recently we have gotten a 10 billion valuation. And why is this relevant? With the increase of the company size, we have also seen an increase in data growth. We have seen twice the event types that we gotten since 2017. We've gotten twice the data throughput, the number of events since that same time. But another point I would like to focus on is the fact that we have seen an increase in pace on the product launches. To the point where actually got 20 products launched in 20 weeks, which can be quite hard for an analytics team that is trying to drive some product launches analysis and doing other data requests, and we need to keep up with the pace of the company. So another point that I would like to focus, as I was talking about data growth, TalkDesk is event-driven. And this means that for every action, we have an event. And the action is nothing more than the action itself, an actor, and the object, the payload that is associated with it. Related to the contact center, we can have an event that is the call started, that is when a user decides to call the company. He has an issue and he creates this event when he starts the call started. Again, we have the action, call started, we have the actor that is the user, and we have the object, the payload that can be anything from the phone number to the reason why he's calling. Later on, an agent picks up the call and another event is created, like the agent status change. That is nothing more than the pickup of the call and the status that goes from busy, available to busy. And that information is stored in the object of the event. We go on, many things can happen here. Hopefully the client is happy and the whole interaction finishes with a call finished. And again, we have the action, we have the actor, and we have the object. That again can be the IP of the agent and the IP of the user. And why this is relevant? We have seen that we are increasing the number of events, and this is a snapshot from January 2017, where we get the top 10 most frequent events. And in this case, what was true was that by a long margin, contact updated was the most used event. We also had agent updated. These were related to changes to the name and other types of things that we try and update. But some years later, in January 2021, The top 10 are completely different. Now we have something that is the system initialize step and system finish step that are the most frequent ones. And these events are something that became true when we moved on to another system. And now for each call that we get inside an interaction, that is, the user goes to an agent, he tries to solve the problem, he isn't able, it moves on to another agent, and this moves to another step in the whole interaction. And this goes to show how from 17 to now, the business completely changed. And in terms of the analytics teams, we need to keep up to pace. We need to be able to interact with the data, and we need to handle this growth and all of these changes and be as lean as possible. We can just add more people to the problem. At the same time, the architecture that we had is, I'd say it's very common. We had a centralized Redshift, a centralized data warehouse, and all the data was being sent with for analysis. The events came from a Spark processor, and everything else came using Fivetran, either for internal databases that weren't mapped to events and external services like Zuora or Salesforce. This was all great, except the part that we found out two things. First, Redshift is really great for analysis, but it's great for historic analysis. In some other use cases like real time, we can have better with other types of databases. Another thing that I would like to point out was the fact that with the increase of data requests, we started seeing the backlog of the analytics team increasing, and some data requests that were taking some days or weeks were starting to take months, and we weren't being able to keep up the pace. And this meant one thing: if our internal users aren't able to make decisions based on the data, because we can't provide the data in a timely manner, they just churn and start making decisions that are more gut based than the data driven. And this isn't something that we are looking for, and we were looking for how to solve this problem. At the same time, we had around 10 developers between data engineers and data analysts to give an idea of how we were organized. And data mesh appeared at the same time that we are getting these issues. Data mesh is something that was proposed in an article by Zemek Tegani in 2019. And I would like to focus on some of the core values that are proposed in this article. And these are the decentralized ownership and the distributed architecture instead of centralized one, having data and code as one single unit and not as separate entities. Also, instead of a centralized governance, decentralize it. And something that I really resonated with, that is the data as a product and not just an afterthought. Thinking of data as something to use after we have the actual application, the actual product, but think of it as a product itself. So at TalkDesk, we have been doing many things, but in terms of the data mesh architecture, I would like to focus on three things that I think simplify a bit on how we change our mindset to this kind of architecture. And that is using Trino, having data products, and also using dbt. Firstly, what is Trino? Traditionally, with data warehouses like Redshift, Redshift does everything. We insert the data into it, and the Redshift is able to run the computation for the queries, but also stores the data itself. Everything is aggregated. But we try and separate this into separate entities. We have the computation engine, and we also have the data storage, and they must be separate. In this case, Trino is only able to query the data. It's an open source SQL engine. And what is great about this is that Trino has multiple connectors to connect to the databases that actually store the data. In this case, Trino, we can query databases like ScyllaDB, Postgres, MariaDB, or MySQL, or the data warehouses like Redshift or BigQuery. And this is actually great because now using Trino, we can, with a single query, get the data from Redshift, get the data from another database like Postgres or Scala, and merge it all in a left join, like we have at the bottom, and bring it all together to the user isn't aware that there are different databases, and we can keep the data at where we need it more. So with this, instead of having a centralized architecture and having to bring everything to a single data warehouse, we now have a distributed architecture, and we solved one of the first core values in the data mesh. But this isn't enough. As a reminder, our problem is to try and bring more analysis. The analytics team wants to be faster, to be more productive, to do more. And we had another issue, and that is we can query multiple databases, but there is a division, a great divide, I would say, that is also proposed on the data mesh, that is between the operational data and analytical data plane. First, in the operational data, the applications teams that actually create the applications need to have the data in a very normalized schema. This data needs to be prepared for mainly write operations because we are, in this case, adding a new order. We are updating a single row with a contact that was updated, and the data is prepared for this. But when we need to analyze the data, we need to transform it. It can be to a denormalized schema like Kimball or any other thing that we think it's best. But we mostly do read operations. And now, instead of querying some 1,000 rows or only 100 rows, now we need to run some queries that can span months or even years. This can go from to millions or even billions of rows, and we need to have it in single digits of seconds. And this change from operational to analytical is one of the most time-consuming tasks. In the case of an ELT or ETL architecture, this part, the transformation, can take weeks or even months. If it's something really complicated, it's a new feature, it's a new product that's being added to this for analysis. So one thing that we decided to propose, that we decided that was going to help us drive through our analysis, was to think of moving the ownership of the data to the operations teams, to the applications teams that are actually the ones that create the data. They are the owners of their own data. And for this, what occurred was that at the same time that we are having these issues, we had a new product that we decided that we needed to bring to the client. We decided that now each client, customer, needs to be able to access their own data, needs to be able to understand how they are faring, and they become now data users. And for this, what we have done was have an interface. In our case, we have created a self-service BI tool using Looker, but this wasn't enough just to present the data to them. We decided to bring the data to them. They can do anything that they want. And for that, to help increase the pace and help streamline some of the processes, we also built a data platform internally. And this helped us. Why? Now, having the data platform, we started requesting each application team that they created their own data sets. The data that they are generating for the new features, the new products, will be made available almost as soon as possible to the clients. So they need to understand that the data that they create is a product in itself, and they are the owners of these data sets that they should create using the data platform. And finally, as we are thinking for the standpoint of an analytics team, we now can leverage these new data sets that are not created by the data engineers and the data analysts, but are now created by the application teams using the data platform. For this to work, just to give a reference, we joined forces with the reporting team, and this has been really great, and it took us around a year to go from concept to global availability. This is an example of the dashboard. This one was created by the reporting team and business intelligence, but this goes to show one example of the dashboard, but users can query the data as they see fit and create their own dashboards. But this is all great, but the data platform is a core. It's very central for how this all works, from moving the ownership to the teams. And as we are event-driven, what happens is the fact that the events, when they are created, they are inserted into a single queue, what we call a topic in a Kafka cluster that we have. And all these topics are then processed and sent to different queues, which are then processed using an application that we have that is called Broker. And this does everything from the cleaning to the denormalization. And then we send it to another application that is Hermes. And this is nothing more than a materialization of all these events that were cleaned and denormalized into the databases. From the inception of the data to this point, it can take some seconds only. And for that, to have the data prepared for real-time use cases, there are multiple reasons for having this kind of data. We store the data in databases that are prepared for real-time, like MariaDB or even ScyllaDB. And this data can now be queried by the data users, either using some APIs that we provide or using Trino. But later on, we can just keep the data there and we migrate the data to cold storage. In our case, we store it in S3 buckets, and then we can query it using Trino and using the Hive connector in Trino. Again, Trino can query the data using for the Scylla and MariaDB, get also the data for mobs that we have, and join it all together in the single query. Finally, we decide that we have different use cases, and aside from the Trino, the users can also get the data using different APIs. And this is all great because now with the move of datasets to the application teams, we have more time for analysis. And looking at the data mesh core values, we get the decentralized ownership, the federated governance, and we also get the data as a product, not just an afterthought. But this isn't, and we need sometimes to do further transformations aside from the data that is on data platform. And for that, we have Airflow to orchestrate everything. We still use Fivetran for some edge cases and to get external sources. And up until some time, we were using AWS data pipelines. And this wasn't actually great. First, the process was a bit complex, and to release the new data pipelines needed to be added by the data engineer. And the code was repeated. We didn't have many features that we were trying to implement ourselves, but what we found out was that by moving to DBT, we got some things for free, like macros, which allowed us to have a dry code, don't repeat yourself. And for some best practices that DBT implements and enforces, we also got less code to maintain because some features that we are implementing ourselves were almost free. Creating the table and recreating the table, everything is much simpler using DBT. And we have other things like data tests and documentation as code that we get by using DBT. This is an example. Again, we are running DBT in Airflow, and before I couldn't even fit all the code that we had in a single slide, but in a more visual way. What we had before was multiple steps just to create simple tables. And by moving to DBT, we now were able to run these tables on single steps. And this has improved our code and the visibility of everything that we do, which has been really major. But we are also using Trino. And Trino plus DBT, as we now can query data from multiple databases, not a single one. We only need a single repo. We only need a DBT project, a single one to rule them all. We have already migrated some of our tables and views to this. Again, I'm going to explain why we haven't already migrated everything later. And something that is really major by having Trino, I can give an example, is that we had to do a migration from a Mongo database that we had to a Scala database. And while before this could take a long time, it could create a new connect and everything. What happened was that a new connector was added by the other team. The new dataset was added to the Scala database, and we just had to do a renaming, run the data tests, everything was okay, migration done. Another point I would like to focus on is the fact that by moving to dbt plus Airflow, and we also have a bit of continuous integration, CI/CD implemented. What before had to be done by a data engineer can now be done by everyone, by the data analysts also. And this shows in the top maintainers. We have here the top 4 maintainers at the time I took the picture, and actually only one of those is a data engineer, which goes to show how autonomous we currently are. And looking at the data mesh, now we get data and code as a single unit, not separated entities. And again, just to give an idea, we had to grow, we had to do a reorg. Now we have a data platform, and to prepare for the future and to be more capable of increasing with the needs of the whole company. We moved from initially having less than 10 developers to now having around, I think now we are much more capable of working with the rest of the company and sending the new data requests that the internal clients need. Lessons learned. We had some performance issues depending on the connectors. We need to be aware that we need to push down the queries to the database itself, because if Trino isn't able to do this, we need to bring all the data in memory around the query with all the data. But this has been improving with the great work of Starbus. They are the main developers of Trino. And another thing that I would like to focus is the fact that we had to move our mindset from a service team that does data requests to a platform. Now we have a platform. We need to understand that we have metrics of satisfaction. We need to make the platform as simple as possible for the internal clients to create their own data sets. And now we provide a service to our internal users, application teams. Regarding next steps, I would like to say kudos to Marius Grama. He has been the one that has created the dbt Trino adapter, which has now been adopted by Starbus. And we are getting new features being added, like incremental modes. And this has been really great, new features being added. And I really see us moving to these, all the data pipelines that we have to dbt using this new approach. We also have new projects coming up in coming months, like adding data lineage and also adding the tests to the data platform, which I think will improve our internal database and data platform. Talking about the dbt Trino, I hope I have convinced you that this is a viable approach to increase the pace of analytics. And if you are also interested, all feedback and help is welcome. And again, thank you all. Not sure if we have any questions for Kia?
Yeah, we do, Jose. Thank you very much. And I love the double Harry Potter reference there as well. I think we have time for one. There's two questions here that kind of overlapped a bit. It's great in theory. How do you enforce, or how do you drive adoption? You mentioned having a simple setup, etc., and SQL helps. But how do you drive adoption across the board here, which is required for this whole idea to work? And then within that, how do you govern, say, standardization and this sort of thing? What would be your answer there?
I would say that, yeah, this is a moving target. What we are trying to do is make it as simple as possible. And I would say that the pace of the events need to be made first. And this is the first battle that we had to do, is to explain to each application team that as they are creating the applications, they need to also create events. And this is the first obstacle that we had. Another obstacle that we have is to actually add the added work for the teams. And the points that I wanted to focus on the presentation is the fact that by making sure that everyone understands that the data is a product, you are not just releasing a new feature, adding a status mode, adding a new order. You are also making the data itself as a product. When you make available the product, new orders that are being added in the contact center, I would say adding the Slack message feature. The applications team need to understand this is really important, that it's not only the feature. You need to have the events, to have metrics for internally understanding how your product is going on. And you need to understand that the data needs to be available for the client. They need to understand if the messages are going on, how many messages are being sent at the same time in real-time use cases, how many messages have been sent in the past month. And if they are not aware of this, it's really hard to convince them to have the added work. So we try to give this sense of importance of the data, and also we try to streamline as much as possible and is up the building of these data sets.